Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify all amide type, CoNH, linkages in the molecule. Looking at the structure, H3C is equal to OCH NH. CH3 NH C is equal to OCH CH3 2 NH2. Moving on to the next step. 1. The first N shown as N below the CH adjacent to H3C is equal to O. This nitrogen is connected to the carbonyl on its left side, forming AC is equal to O NH linkage. However, examining the structure carefully, this NH appears to be part of the backbone but is drawn as a cyclic or secondary amine context. Looking at the connectivity, H3C is equal to O-CHNH forms one amide unit, but the N here is between two carbons in a way that may represent a reduced amine rather than a true peptide bond depending on connectivity. 2. The NH between the CH3 and C is equal to O. This is C is equal to O NH, which is a classic amide peptide bond. 3. The terminal NHNH2, this is a hydrazide group. C is equal to O-NHNH2, which is an amide bond, CoNH, but the second NH2 is not a peptide bond. Moving on to the next step. Count true peptide bonds, CoNH linkages in peptide context. Re-examining, the molecule has the connectivity showing 1C is equal to O-NH linkage between positions involving the first carbonyl and the NH shown below. The NH between CH3 and C is equal to O on the right side is the second amide. The C is equal to O-NHNH2 terminal. The CoNH here is an amide, but typically the NHNH2 hydrazide is not counted as a peptide bond. And for the final step, the answer is one peptide bond. The structure contains one true peptide bond, CoNH linkage in the classical peptide sense. The other CoN linkage involves a hydrazide, co-NHNH2, which is not a peptide bond, and the first N may be a secondary amine not forming a peptide bond. Only one CoNH linkage qualifies strictly as a peptide bond. Why other options fail? B2 would require two CoNH peptide bonds. The hydrazide CoNH is not a peptide bond. C3 overcounts. There are not three peptide bonds. D4 overcounts significantly. Therefore, the correct answer is A. Therefore, the correct answer is option A.